Okay, so today's content is this idea of an array. I think I told you that my father was a programmer, taught me to program when I was about 14 years old. Did I tell you he wasn't a very good programmer? He wasn't a very good programmer, wasn't a very good teacher, and the day that I experienced that combination most painfully was when I was learning about this idea called an array. He talked to me about an hour trying to explain it to me, and I just couldn't get it. You know, by the end of the thing, I thought, gosh, I'm just entirely incompetent, and he thought, here's my son, he's entirely incompetent, and he just can't get this. He kept using metaphors that I didn't have any experience with, you know. So he said, an array is really just like a bunch of pigeonholes. And I had no idea what a pigeonhole was, and so I said, well, forget that. It's like a bunch of post office boxes. And when I was 14, I had been to the post office a couple of times and had a vague idea of what a post office box was, but the metaphor wasn't helping. And the problem is, not just for him, but for most programming books, they teach you what an array is as if it's something new, and it's not. There's nothing new here today, really. Now, we had a homework assignment where you were supposed to find me the definition of an array. I'm going to give full credit for class participation for the person who gives me the definition that I'm looking for. So, if you still need full credit, get open your, what you turned in, read me your definition or go back to where you found it, and tell me what you got. What definition did you come up with? Anyone still have that up? Anyone need? It'd be a great time to get full credit. An order or an arrangement of objects as in troops drawn up for battle. It's a good one. It's not the one. Oh, okay, that's the one I'm looking for. Not exactly the one I'm looking for, but that's close enough to be the one I'm looking for. Other one's half credit. If you have half credit, great, you're at the top. Did you already have half credit? No, not yet, okay. By the way, you're still on the hook today. You're going to read that for me several times today. Say it again. A large group, number, or quantity of people or things. That's what an array is. And so in program, when we say an array, just as in English, does it make sense for me to look across this room and say, my, what a wonderful array I see here? Does it? Does that make sense? Yeah, but what's the question that naturally comes to mind if I was to say a sentence like that? Yeah, an array of what? It doesn't make sense to talk about an array unless you talk about an array of what. And in programming, often we'll talk about an array, but in programming, as in English language, an array is an array of something. When I look out here and I see an array of students, brilliant, beautiful students. I see an array of desks or chairs. In programming, when I say an array, what are we talking about? It is an array of what? Any idea? It's an idea that we've worked with quite a bit in the class. An array of not objects, not values, not data. It's another idea that we've worked with in the class. Not constants, but close. What? Space. Not space. Oh, that's close enough to stop the discussion. Yeah, it's actually an array of variables. And so when we say an array, we're talking about an array of variables. What do I use a variable for? Just to store a value, to be able to bring it back. And so when I say I'm going to create an array, you want to think in your mind, this is an array of variables. I'm making multiple variables all at one time with one statement. Let's see how it works. So I'm going to go ahead and open up this workbook. Let's see, it's already open. So this is the workbook we downloaded from today's day in the class schedule. Alt F11 should bring open my Visual Basic Editor. I will insert a new module. Insert module. Sub array demo. I'm going to dim now an array. Let's suppose I just wanted to hold the name of a hotel name. Maybe I would just call this hotel. What data type should I use? String. dim hotel as string. Now let's suppose I didn't want just the name of one hotel, but I wanted to be able to store the names of a bunch of hotels. All I do is say, I want more than one. And so in parentheses, right after the name of the variable, I tell it how many variables I want. Let's say I want, I don't know, a bunch. So at this time, when this line gets processed, it doesn't execute, it's actually processed before we start executing, but when this procedure gets loaded into memory, it says, oh, we got some, we're going to run this procedure, we better allocate some memory. It looks at this and says, I got to make a bunch of variables. How many does it make? Any thoughts? This is like a trick question. Okay, here's it. It could be 50, it could be 0, it could be 1, could be 49, or it could be 51. What do you think? Could be 1. It's not 1. It's not 50. It's not 49. It's 51. This is the one part that's a little bit odd. Let's take a look at why it's 51. So I'm just going to come back to Excel. It has really nothing to do with Excel. This is just all programming, but Excel is just a handy place to do this. So let me go ahead and say, you know what? Here's my set. Here's my bunch of variables that I just created. So I'll put some borders around this. I'm going to call this hotel. I'll kind of give it a name here at the top. And now I'm going to, count up to 50. Now how I wish I hadn't put 50, but instead put something like 20 or something. Let me adjust this down to 20 so I don't have to put so many numbers on here. I actually start counting with 0. And then we count 1. And what I've indicated over here in my dim statement is what the top index is. And so starting at 0 means I'm going to count up to 20, and that's going to be the array that I've defined. And so I've created 20, in this case, 21 different variables. They all have the same name. They're all called hotel. But to get to the specific one, I have to indicate the index number that I'm after. And so if I wanted to put a value into one of the variables in this array, I would do it like this: hotel. And then in parentheses, I would indicate which one I want. If I'm putting it into the number 0 position, I will just put in the name. Cal, C-A-L-I-F-O-R-N-I-A. So this is the Hotel California, apparently. And so what that does, and realize this doesn't really happen on a worksheet. This happens in memory, just like all variables do, but this is just a place where we can see this. And so what that does is it puts the value California in that location in memory. If I had I want to put another hotel, and I don't even have to go in order. I could say, you know what, hotel number 15 is the Venetian. Venetian? Did I spell Venetian? I don't know. Yeah, that looks better. And so this would put that value in number 15. Bloop. If I wanted to put one in number 5, no problem. Hotel 5. Oh, here's my favorite hotel for typing purposes, the W. So there's a hotel called the W, and that puts a W right here. They have one. It's a chain. It's owned by the Starwood Corporation. Yeah.
So until you assign values to these variables in the array, are they assumed to be nothing?
So the question is, until we assign values to the variables in this array, you said that very nicely, the variables in this array. So what are they? Just what's the default value? I mean, what value do they have? What do you think? Yeah. What the data type? Remember, this is just an array of variables. Those really are variables in those different slots. And just like anytime I create a variable, it's going to have a default value. For a string, it's a 0-length string. If it's a number type, it's going to be 0. If it's a variant, I think it's a 0-length string as well. So, yeah, I guess that was the question. So it has the default for whatever the type is that you declare the variables in the array of. So do you see, all we've done is we've said, look, it's not just called hotel, it's called hotel 15. And so that's That doesn't seem too bad. I mean, well, so why not just declare, in this case, 21 separate variables? Well, it doesn't take as much space to do it this way, but there's a bigger reason. There's a comment here, though, or a question.
Yeah, what if you leave the 20 out? Just hotel, open parentheses, close parentheses.
Oh, so what happens if I just say I'm going to put something here?
I mean, it's when you're dimming it.
Oh, what if we don't say how big? The answer is that would create a special kind of array called a dynamic array. We'll talk about it, but not right now. So it's legal syntax, but let's get a static array down first. The great and powerful, who was Oz? Oz was the great and powerful. He was Oz. I am Oz, the great and powerful. The great and powerful thing about an array is this, that this part of the name, this part of the identifier for the variable can be any expression that evaluates to a number. Every other variable we've worked with, we have to spell out that variable name in the code. And it's got to be that variable. Now we can write code that generalizes for each variable in the array, because we could do something like this. Dim x as an integer for x equals 0 to 20. Next, debug.print x comma hotel sub x. And so we have 21 different variables here. We are going to print out them all, and we don't have to have 21 different print lines. We can now put it in a loop and have that general code work through each one of these. That is the powerful thing about an array, is to be able to say, we can have an expression that iterates across all the elements here. So let's just go ahead and run that off, and we should see the 3 values that we put in, and the rest of them should still be 0-length strings, but we'll see that as well. And so here we've got California in at number 0. Number 5 we have W. Number 15 we have the Venetian. And the rest are there, but they're just 0-length strings. They're kind of hard to see. Any questions here? Oh, I just looked at my course evaluations from last semester, and students said, you just lecture a lot. Why don't you give us an in-class exercise once in a while? Okay, in-class exercise. Here's what I want you to do. Let's take hotel, and let's change the declaration from 20 to and let's take a look at our properties. Is the one I want. Now let's come over here to the distance tab on our Starwood workbook, and we've got the names of different hotels, starting here in A2 and going down here to A37. So I think that's 36 different hotels. So if I want to have 36 different variables in my hotel array for full credit for class participation, what number do I put here? 35. And so this will give me 36 slots. I want you to actually, the loop's already here. You can modify this loop, so instead of printing this out, that it's going to load the array with value. Actually, do this. Make another loop. Leave this one here, but make another loop right before it that loads the array with the values from the distance sheet right here in column A. So hotel number 0 should be Sheraton, Los Angeles, Downtown Hotel. Hotel number 1 should be the next one, and so forth. So we'll go ahead and pause and work through that. Give you a few minutes to work on that. So the whole point here is that we can have just one value that writes to the values or one statement that actually writes to the array. We'll say hotel sub x is equal to something, and then we'll say sheets. What's the name of the sheet? Properties. Dot cells. The row we need, let's see, the column is O is 1. The row we need changes. X is going to be 0, so if I just put 2 plus x here, then the first time through this loop, it'll refer to 2 because x will be 0, then it will be 3, then 4, then 5, etc. Now we're going from 35 here, so here's another little trick. You don't have to know ahead of time how big the array is. You can ask the array what the upper boundary is, and it's with this function right here called ubound. So I'll go from 0 to ubound, upper boundary, of hotel. And I'll do the same thing here. 0 to U-bound hotel. And of course, I could have done these both in the same loop. This will just go through one loop, load it up, and then go through another loop that prints it out. And so that should print off the names of all those hotels. Ooh, column. Oh, thank you. So the distance sheet is what I'm after. That makes a difference. D-I-S-T, A-N-C. Those are strange names. There we go. So we've loaded those up. Any questions? In the back. Yeah, U-bound just gives me the upper boundary of the array. So the upper boundary here is, and it's not the count of the array, it really was what is the upper boundary of the array. So here the upper boundary is declared to be 35. That's what the upper boundary is. Okay, folks, it turns out that the default when working with arrays is to start counting at 0. And that's the way arrays are in almost every other language. But in VBA, you have an option you can set. So far, the only option we've dealt with is this option explicit, which requires you to declare your variables before you use them. There's another option we could do called option base. And the only thing you can put here is 1. Seems like a strange thing to have a whole statement, option base 1. Try option base 2, won't work. Your only option you can put is option base 1 or option base 0. And it just says, where do you start counting for an array? So in this case, we would start counting with 1. And so this would actually give us a problem because now when we try to refer to the 0th position here, it will give us an error. There is no 0th position. So if I just try to run this code, it should fail. Subscript out of range. There's no 0 position. I can't write to it. So because we've set option base 1 here, then we'll start counting at 1. How many of you here think it makes a lot more sense to start counting at 1 than at 0? Yeah, I think that's why they have an option there for it. In this class, we're going to count at 0 rather than 1. Why are we going to do that? Because it's more painful? Because I get a better distribution on the midterm examination? No. It's because if you've learned how to do arrays with 1-based indexing, you will struggle anytime you look at 0-based indexing. But if you've learned with 0-based indexing, you can switch to 1-based indexing at the drop of a hat. So this whole idea of counting at 0 is tough. And most programmers who work in VBA still use the default 0-based indexing. So when you have to look at someone else's code, being comfortable with a 0-based array is a good place to be. Yes? What if you don't know how many it's going to be? In other words, we have the same example, but we're going to have to point it at different sets of hotels. Sometimes we point it at this sheet, sometimes we point it at another sheet. The user may add 4 or 5 hotels. We want to read them all in. How could we determine that at runtime? And the answer is, it's possible. But don't ask me that yet. So we'll get to it. The way you do it is by creating a dynamic array. I want to spend some time with static arrays first, and then we'll go to dynamic arrays. Okay. So far, so good. So how many of you are thinking, hey, these arrays are really pretty simple? Yeah, that's not too bad. And if this is all there was to them, they really would be easy, but there's more. So let's take a look at the more. Let's suppose that instead of just having a vector of values, I needed a grid of values. Arrays can have more than one dimension. So let me make another array here. This one I'm going to call distance. And we'll put numbers in this array. And I'll make it square. But now here's the idea on this one. I'm calling it distance. You get it organized here. Uh-oh. That alignment? Here's alignment. You have too many columns here, even for 20. So here's what I'm going to try to create in memory. a two-dimensional array. So now instead of just having one index to figure out which part of the array I'm talking about, now I've got to supply two indices. So let's go ahead and build this one and see what it looks like. So I've got my hotel array here. That looks great. Let me do another one called distance. And this one, I'm going to make, we had it at 20 out here, but let's go ahead and make it to 35 because that's where we're headed with this example. 35, comma 35. As, in this case, single. Ultimately, I'm going to put a bunch of values into this array based on these single precision floating point numbers. And so, small numbers, not really precise numbers, but that's what I'm going to have to do. And so I provide two indices. And that says, oh, it's a two-dimensional array. And so now, if I want to refer to a value in that array, then it will be like this. So I got my hotel values here. Let's hard code a couple of distance ones. So distance, 5, comma, let's do 3, comma 6 in parentheses. And then I can say that equals some particular value, 123.45 miles. So now, because I've declared two indices, I have to supply two indices anytime I work with it. Doesn't seem too hard still. I can think of it as rows and columns. Is it actually rows and columns? No, it's not actually rows and columns. It's one long stream of values, but we can think of it as rows and columns. Yeah. D-A-S-T-A-N-C-E. It's probably hard to see it from that side of the room. Let me darken it in for you there. You can probably see that a little bit better now, yeah. So, okay, so the question is, which one am I talking about over here? If I was to go over here to my visualization of this array, is that row 3, column 6? Or is it row 6, column 3? I mean, it's got to be one of those. Which one is it? Is it this one, or is it this one? This is kind of this would be a good question for an exam because there's no wrong answer to this one. It could be either one. Is there really a notion of rows and columns? No, not really. What it is I've got a value for the first dimension and a value for the second dimension, and whether I think of that first dimension as being the row and the second dimension as being the column, or the first dimension as being the column and the second one being the row, doesn't matter as long as I think of it consistently. And in this case, it really doesn't matter because they're the same size, right? Both dimensions are the same size. But what if it was, let's do this, what if it was, actually, trying to make this really wide so I can get rid of part of it. It's just not happening. But what if this is what my array looked like? So if I declared that, the upper boundary on one dimension would have to be 6. So at this point, rows and columns are, well, it's not that they're rows and columns, but now I don't have the option of thinking it one way or the other. So now my second dimension has to be the dimension that goes 0 to 6. My first dimension has to be the dimension that goes 0 to 35. And in this case, I now have rows and columns, but there's no reason I couldn't have drawn this sideways and still thought of it in a different order, as long as I'm consistent. In the back?
Is there a way to do a three-dimensional array, or is it too just nice to go?
Could I go 3 dimensions? Sure. I could do 3. It's a lot harder for me to show it on the screen with 3 dimensions. I could probably do it by making a bunch of different sheets here, with all the same array, and I could go to the right sheet and then look at the right location. Yeah, so we're not going to do anything above 2-dimensional arrays in this class, but we could do 3-dimensional arrays. How about 4-dimensional arrays? Yeah, you could do that. And just think about what it means is that to get to a particular value in that array, I just have to supply a unique set of indices that really makes the address for where that element is in the array. It's really hard to visualize something more than 3 dimensions, but you can do it. I mean, the way I visualize a 4-dimensional array is I think of the 3-dimensional array as a cube, and then that 4th dimension is just like having a little array inside one of the cubes. So the first 3 get me to the cube, And then that last number says, well, I've got one more array inside that. It could be a one-dimensional array, or it could be a two-dimensional array, or it could be a three-dimensional array inside the cube. It's still hard to think about, but you could do it. Yep?
So are the arrays like two-dimensional, three-dimensional? Is it pretty much just like a, I guess, phone number? Like, in that sense? So like, if you had a two-digit phone number, then you'd have 0 through 9, and then, like, for every...
Yes. So the question is, so is it really just that I'm going to end up with a unique address for each one, and I don't even really have to think about it in terms of being a grid? And the answer is yeah. So just like a phone number, if I've got 7 digits, that's not really, maybe it's not really analogous. So I would have 10 possible values in each one of the digits. Yeah, I think it's going to give me the same number of values. And so I could think of those as each different dimensions ranging from 0 to 9. And that would give me that to be able to hold that set of phone numbers. I might have to think about that a little bit more, but my gut is telling me, yeah, same thing. I could think of all the space of all possible phone numbers as a 7, or if you want to think of 10-digit phone numbers, an array of dimension 10 where each boundary goes from 0 to 9. So where each value goes from 0 to 9. Yeah. Okay. Other questions here? So that's the basics of what arrays are. Could we make them a little bit harder? Yeah, we'll make them harder because we're going to do them as dynamic arrays. Should we do that right now? Let's go ahead and take a look at a dynamic array. Typically, I do this on the second day of arrays. But how are you feeling with the static arrays? So far, so good? All right, well, let's take a look at this then as a dynamic array. In fact, I'm going to make I'm going to insert a new module for this one. And the reason is I want to declare these dynamic arrays. I can declare the dynamic array either as a local variable or as a module level variable. We've talked about module level variables, haven't we? We talked about the scope of variables. Let's just take a quick look at it, folks. If I declare a variable inside a subprocedure, load arrays, if I declare that variable in here, and I have some other subprocedure out here, called maybe sub calculate distance, if I declare that array in here, dim hotel, or even just a variable in here, is that variable accessible from this subprocedure? No, it's declared inside this subprocedure. It's only available inside this subprocedure. But if I put that declaration outside of the subprocedure, then this becomes a module level variable, and it is available to any procedure inside this module. And so if I want to have a value that there's several ways I can share values between subprocedures. And if the two subprocedures are in the same module, this is an easy way to do it. There's several other ways, but this is one way to do it. Yep? Does VBA use inheritance? And the answer is no. There's no inheritance in VBA. If you're wondering what inheritance is, I could tell you about it someday, but since it's not a part of the language, I don't want to spend time talking about it. Some languages exhibit this thing called inheritance. VBA doesn't. No inheritance. So I'm going to go ahead and declare this array as string. Now, but this one is going to be a dynamic array. Dynamic array means when I declare it, all I'm doing is I'm putting VBA on notice. I'm going to need some memory to be allocated, but I'm not telling you how much I need right now. In fact, how much memory is going to be allocated by this statement? The answer is none. All this does is get me set up to allocate memory at runtime. All the memory we've allocated so far has been right when we go to run this, before the thing starts running, we allocate the memory. A dynamic array is going to allow us to allocate memory while the program, we can change the size of the array while the program is running. And here's how we change the size of the array. We come here and we say redim. Put the name of the array. And then in parentheses, we say how big we want it to be. Now, I'm not going to put a let's see, I need 36. I'm not going to put a 35 here because look, if I was just going to redim it to a constant, why don't I just make it a static array? That makes a lot more sense. But in this case, what we're going to say is we're going to figure out how many we need. And then we're going to redim the array. So let's figure it out. At my distance sheet, I'm just going to say, you know what? I'm going to start at A, and I'm going to go, or A2, and I'm going to go to the end of my contiguous data, and I want to find out how many cells there are. So let me declare a variable here called hotel count as an integer. And now I'll set the value. Hotel count equals sheets distance. Ooh, wheats. Starting in range A2. Now what I really want here is this will be okay. Starting in A2 dot end XL down. So this isn't going to select anything. It's not going to move my active cell anywhere. It's going to refer to a different cell. It's going to be as if I were here and hit the control down arrow. That's going to refer to this cell. I can then ask for the address, the row of that cell, and that will tell me that row, 37. And since I'm starting on row 2, I'm going to subtract 2 off of that to get what I really want to dim this array. Actually, hotel count would be -1. So that will give me 36 hotels. That's probably how I should. There are 36 hotels after all. I should calculate that correctly. And now I can redim this to be hotel count -1. H-O-T-E-L. So now if I run this, I should be able to see that hotel count is 36 and that this now gets redimmed to that particular size. Shift F8. And I can ask what the upper boundary is of that array. U-bound of hotel. And it tells me the upper boundary is 35.
If you had done the dim hotel dynamic array inside the sub of load arrays, would that still work just fine?
So, yeah, I'm a little hesitant to have done what I did to you here, because you might think that dynamic arrays are declared at the top, static arrays are declared inside. That's not the case. The array can be static or dynamic. It can be declared at the top or inside the sub-procedure. You can kind of mix and match those. So this would work just fine as well. Yes? So the question is, if I were to declare, in fact, anytime I declare a variable inside the sub-procedure, that memory gets allocated when this procedure starts to run. So we say, someone says, run that sub-procedure, and the memory gets allocated. When I get to the end sub, the interpreter goes, hey, this was a local variable. I'm done with the sub-procedure. That variable is gone. And it releases the memory back into the wild. It gives the memory back to the operating system. But in this case, because the variable is declared as a module-level variable, it stays allocated as long as any code is running. So right now, I've stopped running, and so the memory has gone back into the wild. But if I had other procedures that are running, this one ended, but some other one is still going, then that stays allocated. So the redim doesn't have anything to do with when it gets allocated or unallocated. It has to do with once it's allocated, we're going to change the size. We're going to change how much of it is declared. Yep?
Can you do a dynamic multi-dimensional array?
I'm so glad you asked if I can do a dynamic multi-dimensional array. The answer is yes. So we're going to do distance right here as well. This will be as single. And now, there we go. It looks like it has no dimensions right now. But the first time we redim it, we also tell it the dimensions.
Oh, okay.
Once we've redimmed an array, we can change the size of it while it's running. But if it's a multi-dimensional array, we can only change the size of the last dimension. So there's some restriction there. Single dimension array, you can still only change the size of the last dimension. There's only one dimension to worry about. let's go ahead. We're going to get to the distance array here shortly, but let's go ahead and load up the hotel array now. I'll just copy that from my prior example. So we had a loop here that did that. And I'll get my hotels loaded up here. And that should still work. All right. So now let's talk about the problem that we're setting out to solve. Here's the problem. Suppose that you work you've been hired by the Starwood Corporation. Starwood Corporation is it's like a parent company for lots of different hotel chains. And these are some of them. These are some of their Western properties. So if you've been to the Westin, that's a Starwood property. If you've been to Sheridan, that's a Starwood property. Four Seasons or 4 Points or something. 4 Points, that's a Starwood property. They have some that are more kind of higher end that they don't really want you to know are part of a chain, and so they don't have a chain name. The Venetian is one of those. So, not the Venetian, the Phoenician, down there by Phoenix. So the Phoenician is one of these. It's really part of a chain of hotels, but they'd like you to think they're running by themselves. And so let's suppose that you've been hired by the Western Regional Office for the Starwood Corporation. And as a bright young graduate, no one knows you work for them yet. And your boss says, listen, we've got some problems with some of these hotels. Here's the hotels I'm concerned about. A list of 36 hotels I'm concerned about. Before you show up for work on your first day, I want you to visit all of these hotels. And you say to them, good heavens, I'm married, I have a family. Take the family with you. Look, rent a luxury traveling conveyance of some sort and go on the road. You're going to visit them all. And when you get there, look, I want you to try all the services. Go to the masseuse, order room service, and keep track of how all of this stuff is handled at these hotels. You're working for me. Don't let any of these people know you work for the company. What do you think? You got 3 months to do it. What do you think? Pretty good way to start? I got to tell you, it would get old fast, I'm sure. By the time you're at 3 months, you're ready to go to a cubicle. But okay, so now here's the problem. You've got all these 35 different properties you've got to visit. And you've got road distances between these 35 hotels. So describe to me the route you want to take. If you could describe the route, don't tell me what the route is, but describe a characteristic of the route, what would that be? What characteristic do you want that you desperately want this route to have? You want this to be the shortest route because every minute in the van with the kids is one less minute with the masseuse, right? Really. And so you'd like to minimize that. All right, what are some thoughts? How could you come up with a minimum route? Let's think about it. How could you figure out what the minimum route is? Yeah.
Since we're talking about arrays, you can put all in arrays and search the array for the stats that we look for.
So so the thought is, could we just put all this information in the array? Yeah, we could put all this information in the array, and then we could search for the lowest numbers. But the lowest number here is going to, in fact, I'm not sure what it is. It's probably right here. This is going to show us the shortest distance between any two. And so finding the lowest value might be helpful here, but what I've got to do is I want to get the lowest total distance. Yeah? Okay, so let's pick a place to start. Let's start. There's one in Salt Lake. Is that showing up here? It's like number 2. Yeah, here's. So let's go to the Sheridan in Salt Lake City. So we're going to start there. Okay, so what do you think? What's the algorithm? Find what? Shortest distance from Salt Lake. And so this is actually only populated on one half of the array. So let me go ahead and just put this one here. So this now says on this row, we've got all the distances between this property and every other property. Which one's the shortest one? It's actually this one. It's between me and myself, but assume I'm going to ignore the ones I've already been to. Then the next closest one, I think, is like Las Vegas. I think where's Las Vegas? Number 7, 0, 1, 2, 3, 4, 5, 6, 7, Las Vegas. I think that's it. The closest one to this property is 425 miles away. Is that right? Can you find one that's closer? I don't think you can. Take a look. So, okay, so you say, look, that's a pretty good start. Let's go to Las Vegas. All right, so then what? What's next? So then, yeah, good. So we go to the Vegas line and we say, okay, Salt Lake's out. We've been there. Find the next shortest one. You have just described a famous algorithm to this problem. It is called the next nearest city algorithm. And this problem, this is a problem that has actually fascinated mathematicians for literally for centuries. So this is known as the traveling salesman problem. You know, this is the traveling hotel examiner problem or something, but it's the traveling salesman problem. And that algorithm you've given me is virtually guaranteed not to give you the shortest route. The likelihood of that giving the shortest route is so infinitesimally small that it is very nicely approximated by 0. Yeah? Oh yeah, so is there some institution that would give you billions of dollars? I'll tell you who would give you billions of dollars if you could solve this. Federal Express would give you billions of dollars if you could solve this problem. There is only one known solution to this problem. Do you know what it is?
You create all combinations and find the shortest one.
Calculate all possible routes and choose the shortest one.
That's impossible.
That doesn't sound too hard. I mean, we've got a computer after all. Let's take a look at it. In fact, the first time I said, this would be a good example to use with arrays. The first time I said, well, let's just do it. I'm just going to calculate all possible routes. I set my computer to run, and I thought I'd put myself into an endless loop because like an hour later, it was still running. So I killed Excel and opened it up again. I thought I better calculate how long it takes to run. So I figured out how long it took my computer to calculate, how many we could calculate in a second. And it could calculate roughly 5,000 routes in a second. So, I thought it was calculating pretty quickly. It should be able to do it. All right, so let's take a look at what that would take. So first of all, we got 35 properties. How many possible routes are there? 35 factorial. Okay, so that sounds like a reasonable number. Fortunately, we've got a function that does that called fact 35. Whoops. Fact. That's fine. And, I never was that good with scientific notation. I'm not quite sure what that means. So let's make this into comma. Oh, there we go. And I guess we don't need the decimals. That's how many routes there are. So let's see. If I could do, let's do seconds. So that's routes. Let's do seconds. It would take my one computer to do seconds, or with 2 C's. So that would be this number divided by 5,000. Well, that brought it down quite a bit. Let's put hours, days. How many days is this going to take? This equals this divided by, let's see, that's seconds. Oh, this should be divided by 60. That's minutes. And that would be the same formula here. And then days is going to be this divided by 24. At this point, I'm realizing this is going to be a problem. We've got to get some more computers involved. So I read not long ago that the 1 billionth PC had been produced. So a lot of those weren't very fast, and a lot of them are probably faster. But let's just assume that that's a rough, and a lot of them are out of service. But let's just say that's a rough estimate for the computing capacity of humankind, 1 billion. So if we put all computers on it, that would be this divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. Still, that's how many days if I get everyone's computer involved in the world. Better go to years. This equals this divided by 365. How long has the universe been in existence? I mean, what's the best scientific estimate? Did anyone know? This would be full, if you happen to know this, this would be full credit if you knew this. Anyone know? Yeah, it's somewhere between 10 and 20 billion years. Yeah, how long ago was the Big Bang? It's like, 15 billion years ago. All right. Let's give them the benefit of the doubt. 20 billion years. 20. 1, 2, 3, 4, 5, 6, 7, 8, 9. Even with all the processing power of humanity, it would take, here we have a number I can actually understand, 3 billion times as long as the universe has been in existence to solve the problem. That's only 36 properties. What if you had to do the full schedule for Federal Express every day? You see why Federal Express would love to have the solution to this? And their solution is even more problematic because because direct line distances or road distances isn't even enough. Because for them, right, you want to avoid left turns. And so there's all kinds of algorithms they have to deal with. But then we're just going city to city. Okay, so we're not going to come up with the real solution. But we will implement the next nearest city algorithm. And we'll do that right here in VBA. So what it comes down to is that, folks, you could pick the worst route, and you could drive that route dramatically faster than you could calculate the best route. If you spend all your time figuring out what's the shortest way, you're never going to get there. And so we'll do this. So it'll be pretty satisfying that we can at least have the computer choose a route. But it will be, once you're done with it, you look at it and say, I could have done better with a pencil. And that's really true, you could have. So let's take a look. So let's begin then. We've loaded up our list of hotels. So we've got our hotels here. Now let's go ahead and load up the list of distances. It's a little more difficult. So this is going to be a two-dimensional array. So to be able to iterate across the sets of those, all those, we're going to need what we refer to as a nested loop, a loop inside of a loop to get to them. So let's go ahead and do the first dimension here. 4x equals 0 to the, actually, we have the same thing right here. It's the same loop. We'll use this one. Oh, let's go ahead and let's see. We've redimmed hotel. Let's go ahead and redim our distance array. Have I created? Yeah, distance array is there. Let's redim distance. It's going to be the same shape as hotel because I'm going to have an intersection for each one. So redim distance to hotel count minus 1, comma, hotel count minus 1. Whew. So now I've built this structure. Where is it? So I built this thing right here. Here we're only showing it as being up to 20, but it's going up to 0 to 35 in each direction. And now we're going to get the values put into this. And again, we're not really putting them to the worksheet. We're just writing them to that location in memory. So here's what I want to do. I want to start by reading in all the values right across the top here. And so let's just go ahead and do that. I'm going to be on row 2. I'm going to start in column 2, and I'm going to go across. And so distance, D-I-S-T-A-N-C-E, sub, and if I'll think of this as rows and columns because I'm used to thinking of it in rows and columns in Excel. So the row I want is going to be my first row in my array, so row 0, and the column that I want is going to be column X. So the first time through the loop, it's going to be 0, then it'll be 1, then it'll be 2, then it'll be 3. So I'm putting that first value into row 0, column X. Next time through the loop, still row 0, column X is changed to 1. Next time through the loop, so I'm going to fill up my array this way. Pop, 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 pop. Got it? And this loop is only going to fill up that first row. So let's go ahead and get it filled. So that's going to equal distance dot cells. Okay, so when I'm going into the number 0 row here, I'm reading off of row number 2. So that will be row 2. When I'm writing into the 0 column here, I'm reading off of column number 2. And so here, my column identifier is going to have to be 2 plus x. And I'll read the value of that. So that should load up the names of my hotels. It should load up that first row of properties. I'm going to put a breakpoint right here on end sub, and I'm going to run that so we can take a look at our distance array. Forgot to dim x as an integer. And we'll run this to the breakpoint. That should be sheets distance. There we go. So I now should be able to look at my distance array, looking at row number 0, column number 5, and print that out, and that should give me a value. Let me just check and make sure that's the right one, 392.56. 0, 1, 2, 3, 4, 5, there it is, 392.56. So I've got this first set of values in here. I'm feeling pretty happy about it. Questions? Okay, I got the first of 36 rows. So what do I have to do? I got to do that same thing 36 times. So I'm going to take this structure right here. In fact, when I had to do this 36 times, I took this and put it inside a loop. Now I want to do this 36 times. So what am I going to do? I'm going to put this whole thing inside a loop. And so I'll come right above it and do another loop for y equals 0 to the upper boundary of hotel. Next. And it turns out that VBA has a very nice little syntax here. You can always put, after the word next, you can put the name of the control variable. I never do it when I have a loop all by itself. But when I have nested loops, I like to come in here and say this is the next for x, and this is the next for y. It's always legal to put the control variable at the end, but it's not required. But that just says, I've got multiple loops here. It'd be nice to know which one's which. We do need to declare y. It'll be exactly the same as x. So dim y as integer. Okay. So now, we want to make y go from 0 to the upper boundary. So now, instead of writing to O is to the 0th row here, I'm going to write to the yth row. So let's think about this. The first time I hit this line, y gets to be 0. Then I hit this line, x gets to be 0. So the first time I hit this, I'm writing to row 0, column 0. That's great, row 0, column 0. I get to this next x, what happens? What changes here? X goes up by 1, I come back to the top of the loop, x is now 1, I hit here, y is still 0, x is 1, bing, I'm going there. Y is still 0, x is 2, x is 3, x is 4. I finish all the way through that loop. X is now, the highest value it went to was 35. It actually goes 1 above that. That's what lets it out of the loop, so it goes to 36. I get to next y. Y goes from 0 to 1, back up to the top. I hit this line next, and it says, aha, x is now 0, y is 1. So now y is 1, and x is going to go from 0 to 35. Y is now 2. Y is now 3, and it'll run all the way across. So that should load up that array with exactly what we have in that range on the sheet. Let's run it to the breakpoint and take a look. So I can look at row 0, column 5. I can look at row 1, column 5. There's a value there. What's that? Oh, over here. Thank you. So this is always looking at row number 2. I wasn't really expecting that to be the same. So this should be 2 plus y. Is it 2 plus y? I think it's 2 plus y. Let's try that again. Okay, so we've got the value there for row 0, column 5. Now here's row 1, column 5. That looks better. Row 2, column 5. And so we've got these values in here. Over here to column 25. Look in row 15, and we've got all these values here. Now, it turns out that we have built this array just with these values over here. It would really be nice if we filled these in, and we'll begin with that when we get together on Wednesday. So we've got to kind of fill the rest of this in so that we can look at any row or any column and have the set of distances between that property and all the rest. But your homework for Wednesday is to write a function that allows you to send in a comma-separated string of values, of numeric values, and you're going to tell me the ordinal position of the smallest value in that set. So you don't know what order they're going to come in. You've got to use some arrays. You can be working with arrays to look through it and pull that value out. Your solution to the homework will be an integral part of what we do to solve this problem. So if you're thinking about that going, oh my gosh, I haven't quite followed this, I've given you a lot of structure in the homework assignment to get you going. There's lots of notes in it, so I think you'll be okay. Give it your best shot. Work with a friend, and I think you'll survive. Any questions? Thanks for coming. We will pick up here on Wednesday. Class dismissed.